The question says vector p is equal to 3i minus 4j plus 10k, and vector r equals minus 9j plus 7k. Vector q equals 8i plus 14k, and it is this definition was given. They said if m is equal to 3 times vector p plus vector r plus minus 2 vector q, we should find the modulus of vector m. This is going to be a very interesting question.
All right, today we have a problem before us, and they're asking us to find the modulus of vector m. Of course, this problem that we have is from vector analysis. So we have this problem from vector analysis. We're told that vector p is equal to 8i minus 4j plus 10k. Vector r is equal to minus 9j plus 7k. Vector q is equal to 8i plus 14k. And vector m is defined as 3 times vector p plus vector r plus 2 times vector q. So we have to find the modulus of vector m. This is going to be very interesting, so I enjoy you not to go to anywhere. Please just make sure you watch the video to the end. I bet you it's going to be an eye-opener for those of you who have little or no knowledge in vector analysis. All right, so the first thing we're going to do here is to try to interpret this. This is given in terms of 3 unit vector direction. This is 2, this is 2. So we can rewrite this. This first one, there is no I here. So I is 0, which is something as multiplying 0 by I. Then that's going to be minus 9j and then plus 7k, just for purposes of understanding. So this does not have j, so we could write it as 8i plus 0j, then plus 14k. And then, so it looks more like vectors in 3 axes. Now, all of this I, j, k, they are unit vectors in y-axis, so we could represent them, okay? We have the azimuthal axis, we have x-axis, and we have y-axis. So this is z. The unit vectors in these directions are this. We have on the x-axis, we have I, the unit vector there. On the y-axis, we have unit vector j, whereas on the z-axis, we have unit vector k, and all of them at 90 degrees to one another. So that's just a brief knowledge of the unit vectors expressed in terms of these given vectors. So what are we going to do? We come here. The expression, therefore, our vector m, which is defined as this, we're going to have 3. In the place of vector p, we bring in the value of p. That's going to give us 8i, all right, minus 4j plus 10k, then plus r. Vector r is defined as 0i minus 9j plus 7k, all right, all minus. This is 2 multiplying q, so our q is 8i plus 0j plus 14k, all right? So those are just direct, simple substitutions. Okay, so when we have this, we open the bracket. What it means is that our vector m equals 3 times 8i. That's going to give us 24i. 3 times minus 4 is going to be minus 12j. And then 3 times 10k is going to be plus 30k, and then all plus. You retain this one, 0i, all right, minus 9j, then plus 7k, all minus 2 times 8i, that's going to be minus 16, minus 16i, minus 2 times plus 0j, that's going to be plus 0j, minus 2 times 14k, that's going to be minus 28k. All right, I hope you are following how explicit the substitutions are going or went. So what we have now, we have to add or subtract. So you pair up anywhere you have I, like 24i, 0i, minus 16i. So if we compute that, our result is going to be 24 minus 16, that's going to give us 8i, all right? And then minus 12j minus 9j, that's going to give us 21j, all right? Then plus 0j, so it's going to give us minus 21j. Finally, 30k plus 7k, that's going to be 37k. 37k take away 28k plus 9k. Eventually, this is what M stands for, all right? And as we can see it, it's very simple and it's very understandable. But if I were to find the modulus of a vector, if vector A defined as A1 times J plus A1 times I plus A2 times J plus A3 times K. If you have a vector defined in terms of A like this, what it means is that if you want to find the modulus of this vector, it means it's going to be a square root of A1 squared plus A2 squared plus A3 squared. So that's how the definition of modulus of a vector is. So in this case that we have M defined this way, so we can say, therefore, all right, therefore, the modulus of the vector M is equal to the square root. So it's going to be the square root of 8 squared minus, okay, plus, we're going to have it as plus minus 21 all squared, then plus, all right, plus 9 squared. Okay, so if you have this, it will be 64 plus, if you square 21, all right, multiply 21 by itself, this is going to be 21, then you have 21, that's going to be 231. So you have 231 plus 81. So if we add this together, we're going to have is 376, right? 376 under square root. So this result, therefore, we have this. I hope you're learning something. So that's how to determine the modulus of a particular vector.